Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, let's continue the chapter number systems, and today is 9th period. Dear students, yesterday we learned an important concept to be asked in the examination. Can you recall? Yes, what it is? It is rationalization. Then what is a rationalization? Very simple. Converting irrational into rational. Then how do you convert? By multiplying irrational with another irrational. So hence you can define rationalization as the process of converting an irrational number into a rational number by multiplying it with a suitable another irrational number is called rationalization. And this is the number which is multiplied with irrational to convert this into rational. And what do you call this? It is called rationalizing factor. If single term is there, we write rationalizing factor. If two terms like binomial is there, what do you say? You go for conjugate, right? And even we have learned finding the rationalizing factor of sum of the numbers. In general, an irrational number is to be written as nth root of a. Then what about its rationalizing factor? It can be written as a raised to the power 1 minus 1 by n. If root x plus root y is there, what is its rationalizing factor or conjugate? It is root x minus root y. Is it not? Yes. And even we have learned that how to rationalize the denominator. In addition with that, we found out the values of a and b. Yesterday even I had given you two problems. I hope that you have solved them. Now let's go for continuing today's concept. And one more important question is there. It was given in the examination as well. Alright. Yes. This is the question. Just again finding the values of a and b. Find the values of a and b if root 7 minus 1 by root 7 plus 1 minus root 7 plus 1 by root 7 minus 1 equal to a plus b into root 7. Obviously, it can be solved by rationalizing the denominator. How? Look here. Here, I'll go for taking the first term. In the denominator is root 7 plus 1. First, let me write conjugate or rationalizing factor. Conjugate of root 7 plus 1 is root 7 minus 1. And one more. This denominator, root 7 minus 1. Its conjugate is root 7 plus 1. This is equal to here. Root 7 minus 1 by root 7 plus 1. I have taken first term. First, you multiply its conjugate. Root 7 minus 1 by root 7 minus 1 minus, take second term, root 7 plus 1 by root 7 minus 1. What is its conjugate? It is root 7 plus 1. That is to be multiplied to the numerator as well as denominator. Root 7 plus 1. Now, this is equal to a plus b into root 7. This is the first term and is the second term. Denominator, in which form it is? It is a plus b into a minus b. How do you write that? A square minus b square. Alright. Root 7 whole square minus 1 whole square. Then numerator, root 7 minus 1, root 7 minus 1. Root 7 minus 1 whole square. In which form? A minus b whole square. According to that, a square minus 2ab plus b square. What is it? Root 7. b 1. So root 7 1 and it is 1 minus, come to second term. Denominator, again it is of the form a minus b into a plus b. A square minus b square. What is a? It is root 7. b 1. Root 7 plus 1 into root 7 plus 1, it is root 7 plus 1 whole square. again it is in the form of an identity. What is that identity? It is a plus b whole square. According to that, a square plus 2ab plus b square. A is root 7, b is 1. Root 7, 1 and here 1. If you want, you can write a reason here in bracket. A minus b whole square is equal to a square minus 2ab plus b square. Then a plus b whole square can be written as a square plus 2ab plus b square. And one more identity, that is a plus b into a minus b, which is equal to a square minus b square. Next, let's go for simplifying this. It is, what is 7 whole square? Sorry, root 7 whole square is just 7 minus 2 into root 7 into 1. It is 2 root 7 plus 1 whole square is 1. Whole divided by root 7 whole square. Square and root get cancelled. 7 minus 1 whole square 1 minus root 7 whole square 7 plus 2 into root 7 into 1 2 root 7 plus 1 whole square, it is 1 divided by root 7 whole square 7 minus 1 whole square 1. It is equal to RHS is a plus b root 7, and here also I'll write a plus b into root 7. Next, it is simplified. 7 plus 1, 8 minus 2 root 7. What is 7 minus 1? It is 6 minus 7 plus 1, 8 plus 2 root 7. 7 minus 1, 6. It is equal to a plus b into root 7. Now, observe here the denominator terms are same. LCM will be 6. The numerator 8 minus 2 root 7 minus 8 plus 2 root 7. It is equal to a plus b into root 7. When the denominator terms are same, you can go for writing the numerators as it is. Next, denominator 6 as it is. 8 minus 2 root 7 multiplied by minus. Minus 8 minus into plus minus 2 root 7. It is equal to a plus b into root 7. Minus 8 plus 8 get cancelled. Then minus 2 root 7 minus 2 root 7 minus 4 root 7 by 6. It is equal to a plus b into root 7. Cancel it. 2 2s are 2 3s are. We can write minus 3 minus 2 by 3 minus 2 by 3 into root 7 equal to a plus b into root 7. See here, no term is there. I'll write 0 minus 2 by 3 into root 7. Now compare the coefficients, that is a and b. On comparing, you can go for writing the values of a and b. What is in place of a? A is 0. What about in place of b? B is minus 2 by 3. See, this is the method of finding values of a and b. Now, observe. Hope that you all have understood. And another simple method is there to find out the values of a and b for this problem. You can notice that the denominators root 7 plus 1, root 7 minus 1. Can we say that they are conjugate to each other? Yes. Conjugate of root 7 plus 1, root 7 minus 1. Root 7 minus 1, root 7 plus 1. Under such condition, you can go for taking LCM and then go for simplifying. It will be much easier. Got it? You just try that one. Again, you will get the values of a as 0 and b as minus 2 by 3. Now, pausing the video, please copy from there to here. Yes, copy. Yes. Now we shall focus on exercise 1.5. The very first question I have written, observe this. classify the following as rational or irrational. Here they have given some numbers which are rational and which are irrational. You are going to make a table in which you are classifying rational numbers and irrational numbers. I have written them as Q and Q dash. Q is rational, Q dash is irrational. First one is 2 minus root 5. Observing 2 is rational, root 5 is irrational. Difference of a rational and irrational is irrational. Hence, first one comes under irrational, 2 minus root 5. Next, come to second one. Observe 3 plus root 23 minus root 23. 3 plus root 23 minus root 23. Root 23 get cancelled. What will remain? 3. 3 is rational or irrational? It is rational. Hence, second one comes under rational. 3 plus root 23 minus root 23. Next, third one. 2 into root 7 by 7 into root 2. What do you say about this? It is again irrational. Observe. It is irrational. Here I'll write. Third one. 2 into root 7 by 7 into root 2. Next. Fourth one. 1 by root 2. Obviously it is irrational. Fourth one. 1 by root 2. Next. 2 into pi. You all know that pi is an irrational number. Irrational number with a rational number. Product of rational and irrational is irrational only. How pi is irrational? Let me explain about that in the same exercise only. Fifth one, it is irrational. That is 2 into pi. Next, 7 into root 5. Root 5 is irrational into 7. It is rational. So, rational into irrational is irrational. Here I'll write. Sixth one, 7 into root 5. Next, 7 by root 5. Again, root 5 is irrational, 7 is rational, rational by irrational, it is irrational. 7th one is irrational, 7 by root 5. Next, root 2 plus 21. This is also irrational. 8th one. Root 2 plus 21. Pi minus 2. Pi is irrational, 2 is rational. Difference is irrational. Pi minus 9th one. Pi minus 2 is irrational. What about this? 2 into root 25 by 5. See, root 25, 2 into, what about the value of root 25? 5. Divided by 5. 5 get cancelled. 2. What is say about 2? It is rational. Hence we can write 10th one. 2 into root 25 by 5 in rational column. Clear? Okay. Now we will move on to second question. Simplify each of the following expressions. Let me write that. Don't go for copying. Afterwards I'll give you time. It is 3 plus root 3 into 2 plus root. Very simple. Multiplication of binomials. Observe. I'll go for multiplying it directly. Now multiply 3 with both the terms. 3 into 2. 3 2s are 6. Got it? Or else you can write like this. Multiply 3 with 2 plus root 2 plus root 3 with 2 plus root 2. I hope that you have understood. This is equal to, multiply 3 with both. 3 into 2, 6. 3 into root 2, don't write root 6. It is 3 into root 2 only, because they are unlike. Plus root 3 into 2, again 2 into root 3. Root 3 into root 2. See, order is same. Hence you can go for multiplying the radicands. So root 6, it is equal to 3 into root 2, 2 into root 3 plus root 6. Let me write 3 root 2, 2 root 3 plus root 6 plus 6. This is the product. Now I go for taking second one. Second one is so simple. It is 3 plus root 3 into 3 minus root 3. You are able to tell the answer directly also, because first term in both same terms are there, 3 root 3, 3 root 3, only sign is changed. It is a plus b and this is a minus b. What is a plus b into a minus b? A square minus b square. I am going to write it directly. 3 whole square minus root 3 whole square. What is 3 square? 9. Root 3 whole square? 3. 9 minus 3? It is 6. Let me go for taking one more. It is third one. Third one is root 5 plus root 2 whole square. Now could you tell in which form it is? It is of the form a plus b whole square. You can go for expanding it. A plus b whole square is a square plus b square plus 2ab. What is a? Root 5. b root 2. It is root 5. This is root 2. It is equal to root 5 whole square 5. Root 2 whole square 2. Then 2 into root 5 into root 2. It is root 10. Then go for adding these whole numbers. 5 plus 2, 7. You cannot add that to this 2. The reason is it is the coefficient of irrational number. And these two are whole numbers. 5 plus 2, 7 plus 2 into root 10. Next, one more is there. This is also very simple. Here only I go for just adjusting. It is fourth one is given like this. Root 5 minus root 2 into root 5 plus root 2. I hope that you have got the information how to find out the product of this. See that it is terms are same, root 5 root 2, root 5 root 2, but sign is different between them. Here minus, here plus. It is in the form of an identity. What is that identity? Yes, you are right. It is a minus b. Sorry, a plus b into a minus b. What is a plus b into a minus b? It is a square minus b square. Here I write a square minus b square. What is a? Root 5. What is b? Root 2. This is equal to. Now, root 5 whole square, it is 5. Root 2 whole square, 2. 5 minus 2, 3. Clear? So, now, you have to pause the video and should copy from there to here. Observe it. Third question. Recall, pi is defined as the ratio of the circumference of a circle to its diameter. Of course, you are very familiar. See that this is a circle and with center O. And we know that the distance around the circle is circumference. It is equal to 2 pi r, where r is radius. Then, and 2 times of r is diameter. Hence, you can write pi d. But we want pi. Pi is equal to c by d. They have given the same. Recall, pi is defined as the ratio of the circumference of a circle to its diameter. It is. This seems the fact that pi is irrational. How will you resolve this contradiction? Of course, see that c is a rational number. D is a rational number. Rational by rational, it should be rational. But we are telling that it is, pi is irrational. How this is? Now, just I go for giving you the justification for that. See that here is the circle with center O. And what do you call this? It is diameter. The line that joins any 2 points on the circumference of the circle passing through the center, it is the diameter. Now take this diameter and from this point call it as A. And assume that you have taken the measurement of diameter, you start moving around the circle. First it comes here, next it will come here, and third time it comes here. See that it will not measure the full length around a circle exactly. So some amount of gap is left. Then again, take this diameter, divide that into 3 parts. Take one part and just go for measuring. Again, you will go for getting some more gap. Like that, how long you will go for continuing this? So till there will be infinite number of times. Hence, we say that pi has the value whose decimal expansion is non-terminating, non-recurring. There is no end at all. Even we have been using the supercomputers also. With that, we have calculated in the decimal part, we have got trillions of digits. Got it? Only for the sake of calculation, we go for taking it as just 22/7. Understood? Now, you just go through this. See, with the scale or tail, we get only an approximate rational number as a result of our measurement. This is why pi can be approximately represented as a quotient of two rational numbers, that is C and D. So, as a matter of mathematical truth, mathematically pi is irrational. It was proved by Lambert. Okay. Now, let's move on to other questions. Observe here. Other questions are, it is fourth one, represent square root of 9.3 on the number line. We have already represented it. So, it is fourth one is represented. Then we have fifth one. Rationalize the denominator of the following. Here we have few problems. Let's go for solving. Yes, before that, you just go for copying from there to here. Okay, let us focus on fifth one. Rationalize the denominators of the following. In that first one is 1 by root 7. Which is the denominator? It is root 7. To rationalize that, we will go for taking rationalizing factor. What is rationalizing factor of root 7? It is root 7 only. So 1 by root 7 is the given number. This is equal to 1 by root 7 into here root 7 by root 7. Then root 7 into 1, root 7. Root 7 into root 7, root 7 whole square. And square and root get cancelled. Root 7 whole divided by 7. Now 7 is rational. Clear up? Let me take second one. It is 1 by root 7 minus root 6. This is also very simple. Observe it. Here in the denominator, binomial term is there. Root 7 minus root 6. Hence we can go for taking conjugate. What is conjugate of root 7 minus root 6? Yes, you are right. Root 7 plus root 6. Now you go for taking the given number as it is. Root 7 minus root 6. Multiply conjugate to the numerator and denominator. Root 7 plus root 6 by root 7 plus root 6. This is equal to root 7 plus root 6 can be written as it is. Denominator, it is of the form a minus b into a plus b. So a square root 7 whole square minus b square root 6 whole square. Directly you can write 7 minus 6 is 1. It is root 7 plus root 6. Denominator square and root 7 minus 6. Root 7 plus root 6 by, what is 7 minus 6? It is 1. 1 is in the denominator. Rational or irrational? It is rational. Now let me go for taking third one. Third one is also simple. 1 by root 5 plus root 2. Here also you are going to take conjugate. So the conjugate of root 5 plus root 2. What it is? It is root 5 minus root 2. Next, write the statement. 1 by root 5 plus root 2. Multiply conjugate to the numerator and denominator. It is root 5 minus root 2 by root 5 minus root 2. It's equal to. I think you all may be thinking that little bit fast, because already we have solved many problems on this. By this time you should be perfect. Hence I am moving little bit fast. Now root 5 minus root 2 into 1. Root 5 minus root 2. Then it is of the form a plus b into a minus b. A square. Root 5 whole square 5 minus b square. Root 2 whole square 2. You can write it directly. Root 5 whole square minus root 2 whole square. Square and root get cancelled. It is root 5 minus root 2 by 5 minus 2 is equal to root 5 minus root 2 by, what is 5 minus 2? 3. 3 is in the denominator. What is? Rational or irrational? It is a rational number. Understood? And one more is there. Here only I will write fourth one. It is 1 by root 7 minus 2 only. Now, what is the conjugate of denominator? It is root 7 plus 2, right? Now, let me write the given number root 7 minus 2. Multiply conjugate to the numerator as well as denominator. So, root 7 plus 2 by root 7 plus 2. It's equal to, multiply numerator, root 7 plus 2 as it is. Denominator, a plus b into a minus b. A square minus b square. Shall we write directly? A square, root 7 whole square. How much? It is 7 minus b square. 2 whole square. 2 whole square is 4. It is root 7 plus 2 by 7 minus 4 is 3. Clear? Now, what is in the denominator? 3. What type of number it is? Rational or irrational? It is rational. So, observe it. Rational is the denominator. In each problem, denominator rational, then we have converted that into, denominator is irrational, we have converted that into rational. Here irrational, rational. Here irrational and rational. In fourth one also denominator is irrational, then we have rationalized. And what do you call that process? It is called rationalization. Clear? Okay, now you have to pause the video and copy from there to here. Copy this one. Yes. Listen. Here now we are moving to the next part of this chapter, that is laws of exponents, which you are very familiar. In previous classes also you have come across the laws of exponents or laws of indices. If any number is repeated by many times, it can be expressed mathematically called exponents, right? For example, see that 2 into 2 into 2. How many times 2 is repeated? Here 2 is repeated by 3 times, hence it can be written as 2 raised to the power 3. Then here what do you call 2? It is base. 3, it is exponent or power. Clear? This I am going to write this one. Suppose a raised to the power n is there. Here a is called, what is a? It is base. And n is called, it is exponent or index or power. Then laws of exponents, just you are going to recall it. I am taking some simple examples. Observe here. Through these examples only, let us go for writing these laws one after the other. 2 raised to the power 2 by 3. Then into 2 raised to the power 1 by 2. Here, how many exponents are given? 2. Then, observe the bases. The bases are same. What about the powers? Are different. Under such condition, you can go for keeping the base as it is, go for adding powers. That is 2 by 3 plus 1 by 3. Understood? Now this is equal to 2 to the power. Now observe here. Take LCM 3 and numerator. Denominator terms are same. We are kept as it is. Numerator terms 2 plus 1. It is equal to 2 raised to the power. 2 plus 1 is 3. 3 by 3. 3 get cancelled. You will get 2 raised to the power 1. 2 raised to the power 1 is nothing but just 2. Understood? From this example, we can say that if the bases are same, powers can be added. Here I'll write the first law. First law, it is if a raised to the power m into a raised to the power n, we can write a raised to the power m plus n. Now let's go for taking second one. Observe it. This is also very simple one. 7 raised to the power 1 by 5 by 7 raised to the power 1 by 3. How can it be written generally? Yes. Here we have two terms. One term is in the numerator and another one is in the denominator. Here also the bases are same, powers are different. Now I'll write second law as a raised to the power m by a raised to the power n, because powers are different. Under such condition, you can write the base as it is. And power, here 1 by 5 is there. Take this to the numerator. Then it becomes minus 1 by 3. Clear? Now, this is equal to, I am just continuing here only. 7 raised to the power. Take LCM of the denominator. It is 50. Then multiply LCM with the first term. 5 3s are 3 1s are 3. Minus. Multiply LCM with the second term. 3 5s are 5 1s are 5. It is equal to 7 raised to the power minus 2 by 15. Understood? So now we can write a raised to the power m by a raised to the power n is there. We can write it as a raised to the power m minus n. Next, again I go for writing the third law in this only. If a raised to the power minus n is there, this can be written as 1 by a raised to the power n. Hence, you can also write or express this as positive exponent like this. 1 by 7 raised to the power 2 by 50. That's all. If 1 by a raised to the power minus n is there, when it is taken to the numerator, it becomes a raised to the power plus n. Understood? In second example only, we have come to know 3 more. Now, observe that one. Third one. It is 3 raised to the power 1 by 5. Whole raised to the power 4. Observe, base is 3. Power is 1 by 5. Whole power is 4. There are 3 terms. I can write like this. It is a raised to the power m. Then what is there? Whole raised to the power 4. That is, I call that as n. Under such condition, as you have already learned in your previous classes, you can write it as a raised to the power m into n. So now I can write this as 3 raised to the power 1 by 5 into 4. This can be written as 3 raised to the power 4 ones are 4. Then divided by 5. Clear? Go through another example. It is fourth one here. 13 raised to the power 1 by 5 into 17 raised to the power 1 by 5. Now, look here. What will be your observation? In here we have two exponents. In both the exponents, you can notice that 1 by 5, 1 by 5. Means, what do you say? Yes, you are right. The powers are same. What about the base? Bases are different. That means I can go for writing like this. It is a into a raised to the power m into b raised to the power n. This can be written as a raised to the power m, b raised to the power also m. Powers are same, hence I can write a into b whole raised to the power m. Now you can write this as 13 into 17 whole raised to the power 1 by 5. This is equal to, now you can go for multiply 13 and 17. 17 3s are, how much it is? It is 51. 5. 5 is the carry. 17 ones are 17. 17 plus 5, 22. 221 whole raised to the power 1 by 5. Clear? Okay. Now, I go for taking one simple example. Can you tell the value of 5 raised to the power 0? Yes. Its value will be, it is 1. The reason is a raised to the power 0 is 1. Here I'll write that one also. It is 7th one. It is a raised to the power 0 is 1. Do remember, anything raised to the power 0, it is always 1. Suppose 75 raised to the power 0. Value 1. 85 raised to the power 0. 1. 1224 raised to the power 0. Its value is also 1. Clear? So these are the laws of exponents which you have already learnt in your previous classes. Just I have made you to recall these with some examples. Now you have to pause the video and then first you go for writing all these laws of exponents from here to here. Then you go for taking some worked examples. I have taken the simple examples which have been given in your NCERT textbook. Then afterwards we have the exercise. Let's move on to exercise. Copy quickly. Okay, dear students, let's move on to the exercise number 1.6. And this exercise completely based on one laws of exponents, and second one, yesterday only I told you that you should be perfect about the squares of the numbers from 1 to 25, and another one cubes of the numbers from 1 to 10. I hope that you have learned, and based on that, let us make this calculation simple one. Let me take the first one. Find what you are going to find out. Let me give as given in the textbook. It is first one is 64 raised to the power 2. If you have learnt, as I said, immediately you will go for guessing it. 64 raised to the power 1 by 2 is there. What do you say about the base 64? Is it not perfect square? Yes. Then if it is so, it is the square of which number? It is 8 square. 64 can be written as 8 square because 8 8s are 64. Whole raised to the power 1 by 2. Got it? Now we have used the square concept. Square concept has also been learnt in your previous class, that is in A standard. You had a separate chapter called squares and square roots, cubes and cube roots. Observe it. Could you recall which law of exponent can be used? See that. A raised to the power m whole raised to the power n. It is a raised to the power m into n. So we can write 8 raised to the power 2 into 1 by 2. Clear? Only for the sake of understanding I am writing the reason. A raised to the power m whole raised to the power n is equal to a raised to the power mn. Now cancel it. Ones are. It is 2 ones are 2 ones are. 1 ones are 1. 8 raised to the power 1. 8 raised to the power 1 value is 8 itself. That's all. Such a simple problem it is. I go for second one. It is 32 raised to the power 1 by 5. 32 raised to the power 1 by 5. Here also 32. We are very familiar with this simple number. Now, how do you express 32 in the power 5? We do not know. Then obviously you can go for this method. 32. Start dividing it by 2. Why? Because it is an even number. 2 16s are. Now 2 8s are. 2 4s are. 2 2s are. How many times 2? Count it. 1, 2, 3, 4, 5. 32 can be written as 2 raised to the power 5. Whole raised to the power 1 by 5. Again, which law can be used? Yes. Same law. A raised to the power m whole raised to the power n is equal to a raised to the power m into n. Therefore, this can be written as 2 raised to the power 5 into 1 by 5. 5 get cancelled. It is equal to 2 raised to the power 1 is nothing but just 2. Let me go for taking another problem. This is also simple one. It is 125 whole raised to the power 3. You are also very familiar with the number, simple number 125. What do you say about what type of number it is? Is it perfect square or perfect cube? It is perfect cube. If it is so, it is the cube of which number? Yes, you are right. It is 5. How? Just once I just go for showing with the calculation. 125 is there. 5. 2s are 10. 2 will remain. 5 5s are 5. 5s are 5 cube. So 125 is equal to 5 raised to the power 3 whole raised to the power 1 by 3. Again, you can go for cancelling it directly. 3 3. See, every time I am just reducing one step. It is 5 raised to the power 1 is nothing but 5. Now, let's move on to second one. Here also they have given the same. Find. Some numbers are given. In that first one is 9 raised to the power 3 by 2. 9 raised to the power 3 by 2. See, in all these, in first sub questions what they are given, in all these, in the power, numerator is just 1. But here, they are given different numbers. 9 raised to the power 3 by 2. Let us go for finding. 9 raised to the power 3 by 2. Just by observing only, you can come to know that 9 is, what it is? What type of number? It is a perfect square. Square of which number? 3. Because 3 3s are 9. I can write 9 as 3 square. Whole to the power 3 by 2. Shall I cancel 2 and 2 directly? Yes. 2 2 get cancelled. 3 raised to the power 3. What is the value of 3 raised to the power 3? 3 into 3 into 3. 3 3s are 9. 9 3s are 27. Got it? Yes. Second one is 32 raised to the power 2 by 5. 32 raised to the power 2 by 5. Again, here also same. See, how can we write 32 as exponential form? That is 2 raised to the power 5. So, to make the calculation simple, I am going to write it directly. 32 raised to the power 2 by 5 is equal to 2 raised to the power 5 whole raised to the power 2 by 5. 5 5 get cancelled. Now 2 square will remain. What is 2 square? 2 2s are. It is 4. Understood? Yeah. Now you just go for copying from there to here. So copy one after the other with understanding. Yeah. Pause the video and write quickly from there to here. Right here. Yeah. Now let's move on to some more problems. By this we can finish that all exercises. Observe it. It is fourth one. 125 raised to the power 1 by 3. Sorry, minus 1 by 3. Now again we can go for taking 125. What type of number it is? It is a perfect cube and is a cube of 5. So I can write it as 5 raised to the power 3 whole raised to the power minus 1 by 3. Now it is equal to 5 cube into minus 1 by 3. And don't go for simplifying by taking LCM. You can cancel it directly. Now this is equal to 5 raised to the power minus 1. Dear students, you all know that if a raised to the power minus n is there, how do you go for writing? It is 1 by a raised to the power n. Hence, this can be written as 5 raised to the 1 by 5 raised to the power 1 is nothing but just 1 by 5. Now, this is third one. Observe it. First one. 2 raised to the power 2 by 3 and 2 raised to the power 1 by 5. Very simple. Here, the bases are same. That is 2 is there. 2 raised to the power 2 by 3 into 2 raised to the power 1 by 5. It is equal to, how do you go for writing? It is 2 raised to the power 2 by 3 plus 1 by 5. On what basis? When the bases are same, you can go for adding the powers. It is equal to 2 raised to the power. What is the LCM of the denominator? It is 15. Here, two different terms are there, 3 and 5, which are not divisible by any number except 1. Under such condition, just go for multiplying. 3 into 5, 15. That is the LCM. Go for cross multiplication. Calculation will be easier. 5 2s are 10. 3 1s are 3. It is equal to 2 raised to the power 13 by 15. Got it? Yes. Second one. It is 1 by 3 cube whole raised to the power 7. And this can be written as 1 by 3 raised to the power 3 is there. Here power 7 is applicable to both. That is, it is of the form a by b whole raised to the power m. How do you write this? It can be written as a raised to the power m by b raised to the power m. Hence we can write 1 whole raised to the power 7, 3 raised to the power 3 whole raised to the power 7. 1 raised to the power any number is, it is 1. 1 raised to the power 7 is 1. 3 raised to the power 3 whole raised to the power 7. A raised to the power m whole raised to the power n is a raised to the power mn. Hence we can write 3 raised to the power 3 into 7, it is 21. Clear? Okay, now third one, 11 raised to the power 1 by 2 by 11 raised to the power 1 by 4. In which form it is? It is of the form, see that numerator and denominator terms are same, bases are same, and powers are different. It is a raised to the power m by a raised to the power n, can be written as a raised to the power m minus n. Hence we can write 11 raised to the power 1 by 2 minus 1 by 4. And this is equal to 11 raised to the power. What is this? It is 1 by 2. In another word, in another way, it is called half. It is 1 by 4. Other way, quarter. Half minus quarter is quarter. Or you can go for actual method by taking LCM. LCM means 4. Multiply 4 with first term, 2 2s are, 2 1s are. Multiply LCM with second term, 4 get cancelled, 1. It's equal to 11 raised to the power. 2 minus 1 is 1, 1 by 4. Understood? Next, one more. 7 raised to the power 1 by 2 into 8 raised to the power 1 by 2. What can be observed here? Here the powers are same but bases are different. Under such condition, you can go for multiplying the bases, that is 7 and 8. 7 into 8 whole raised to the power 1 by 2. What is 7 8s are? 7 8s are 56. Whole raised to the power 1 by 2. This is the value. Understood? All these are important one, and with this the exercise has been completed. Even your NCERT syllabus has also been completed. And for the examination point of view, just these problems are not enough. Hence we will have to move on to some other additional problems that will be covered in the next class. Okay? Before concluding the class, let me tell you one thing. Whatever we have covered today, please practice them as many times as possible and don't keep anything pending. And second point, so tomorrow, that is on Sunday, we are going to conduct the test on both mathematics and science. So prepare well for that. And the syllabus is in the last 3 days what we have covered in mathematics and science. That will be given. Okay? We prepare well and attend the test as good as possible. So with this, let us stop. Thank you.